Kubernetes components, basically master worker architecture. Okay, so how does Kubernetes looks like? What are the different components inside it, and how do it works? So in our previous video, we have seen about different components, or frequently the terminologies inside Kubernetes, right? So let's see the technical aspects of what is the architecture of Kubernetes and how does it works, right? So we call it as master worker architecture. Okay, it means I have a master, a manager, and there are so many workers. Okay, this is the standard client server based or master slave architecture. Mostly almost all the big tools are based on this architecture. Okay, so we will try to understand this Kubernetes components, right? So this is one view of that. I have two different views of understanding this master worker architecture. Okay, see, cloud provider API, I am just introducing the terms. Kubernetes cluster, inside a cluster I have one control plane, right, and I have nodes. In each node I am having multiple pods. Okay, so we see only kubelet, kubeproxy, right, kubelet and kubeproxy inside each node, and there is something called as control plane. Okay, I have etcd, I have API, I have scheduler, I have CM, CCM, all that we will try to understand. So if you see here, CCM means cloud controller manager. Okay, CCM means cloud controller manager. Okay, CM means controller manager, because this is a control plane, this is the master basically, and these are the workers. These are the workers. Okay, and then we have something called as etcd, basically distribution, right? So distribution / etc. So in Linux environment we have this etcd, where you store the data. Okay, persistent store. Then we have something called kubelet, kubeproxy, and scheduler, right? This is called a node, this is called a node, and this is this white color one, this is your control plane. Okay, so the control plane is the master, this is the master, because it is the cloud controller manager. It has that, it has controller manager, right? It takes care of the API server. It also has a scheduler, right? It takes care of the storing the data. Okay, so then it is connected with the nodes. There are multiple nodes inside a cluster, and each node has multiple pods. So we talked about kubelet. If I just go back here, right? Kubelet runs on each worker node and ensures pods are running as expected. Okay, so inside this node I have lot of pods, P1, P2, P3 running. So whether these pods are working fine or not is taken care by the kubelet. And kubeproxy, right? Kubeproxy manages the networking inside the cluster, ensuring different pods can communicate. So here, when these pods want to talk to each other, right, that is possible using the kubeproxy. Kproxy means kubeproxy. Okay, so these are different components inside Kubernetes. It follows master worker architecture, right? Now let's see the other version of this, right? A little different version of this. If you see now, this is my cluster. I have my control plane. Control plane is my master. Control plane is my master. Okay, then I have the nodes, right? Nodes means worker nodes. This is one worker, this is another worker. So nodes are like virtual machines. This is another virtual machine. In virtual machines I have, you see, I have multiple pods. Sometimes I may have multiple pod, I have single pod. Inside each pod I may have multiple containers or a single container, and the management or taking care of that pods is taken care by the kubelet, and networking is taken care by the kubeproxy, right? So each node has this kubelet and kubeproxy, right? So the health of the pods is taken care by the or managed by the kubelet. Okay, so this is the worker. So there are multiple workers. That's why we say master workers architecture. workers architecture. Okay, so there are so many workers, it means there are so many nodes basically, right? And in master, if you see inside the control plane, if you see, right, I have cloud controller manager, I have etcd, I have a scheduler, I have a control manager, I have an API server. Okay, we will understand these components with a simple restaurant example. I will explain this with a restaurant example, that if you understand Kubernetes completely. Okay, you have to just understand it so that it becomes easy for you to know what the functionality of how Kubernetes works. I will be frequently coming to this slide and showing you what is a cluster, what is a node, what is a kubelet, what is a controller, what is control plane, all that I will be frequently coming back and explaining you with an example of a restaurant. Okay, you go to a restaurant, right. So, as a customer, you are the customer, you will place the order. It means you are giving a request. Once you go to the restaurant, you are giving a request, right. So, you will, let us say I order 2 dosa. I order 2 dosa. Once I give an order, basically we have in this side, okay, let me compare here only. Once I give an order, in Kubernetes there is a YAML file. In this YAML file, I have to write the order. Okay, so I have to tell here a replica. Basically, we call it as a replica. How many? 2. I ordered dosa. How many I want? That is given in this here. Let's say I order 5 here. If I order 5 dosa, then the YAML file has one parameter called replica, which I will be writing as 5. Okay, we will slowly understand this. Now this is the first step, right? You go to the restaurant, you order. Now what happens? This order is not given to the manager. There is somebody, you are telling him, right? So the manager receives the order, takes order from you, right? So this is the API server. This manager is the API server. It means you are giving a request, right? Request is given to a server. So your manager is like the API server. What is his job? His job is to listen to you, continuously listen to you, take your order. His job is just to take your order. It means your request is given to the API server. So the manager's job, the API server's job is to take the order and record it and store it, or submit it. Record it means take that request. Now after this, what happens, right? When I am recording this order, where is the order saved? You are giving an order to me, right? Manager is taking that order. Manager is feeding that in a tab. He has one tab or a mobile phone where he will be loading some data. Whatever you are ordering, that he will be taking care. So where is the data stored? That data, the third step is to store the order. So this data is stored in etcd. Basically, it's a distributed system component where you can store the data. It's a in Linux we call it as distribution. There is one folder where there is something called as /etc. Right. So your order is stored in this etcd. It is like a register. Okay, you understand it as a register where there is a book. In that I am writing order number 1, order number 2, order number 3. That is your etcd. Okay, so we have covered API server here, we have covered about the YAML file and also the etcd, right? It is basically database of, it is the DB of Kubernetes. It is the database of the Kubernetes. After this, what happens? I have to assign this task. Okay, this task should be assigned to somebody. Preparing, I'll start with 2 dosa to start my example. So this order should be, this information that there is a customer who needs two dosa should be informed to the cook. That then only he will prepare. No, it has to, that information has to reach kitchen and there is somebody who has to prepare it. right? So who decides that? So there is the fourth component, called as the scheduler, sorry. What he will do? He will do task assignment. What is the job of the scheduler? Scheduler's job is to assign the work to the chef. Okay, so it is an automatic. Let's say there are two chefs, C1 and C2. He has been informed to prepare dosa 1, he has been prepared to prepare dosa 2. Maybe I am ordering two different types of dosa here. This is some butter dosa and this is some ghee dosa. So chef 1 I told do dosa 1, chef 2 I am telling prepare dosa 2. That is the job of the scheduler. In technical terms, if I tell, right, scheduler is assigning pods to the nodes. It means this is my scheduler, right? What it is doing, it is trying to assign nodes. See, I will create pod 1 here, I may create same pod or different pod depending on the work, right? So these pods are assigned to the nodes. So there is one node, in that node I may have pods. We have seen here, right? See, there is one node and I have some pods here. See, this is the API server, this is the one who is receiving the request, okay, and there is one scheduler who is mapping, who is taking care, giving one dosa to node 1, other dosa to node 2, right? Okay, so I am assigning pods to the nodes, right? Now what is this, where does the processing happens? You see, processing happens inside a node, right? Processing happens inside the nodes, that is inside the worker nodes, So what is these chefs C1, C2 are the workers. Their job is to prepare the dosa based on the requirement. Where they have to prepare? They have to prepare in the assigned pod. They are assigned some pod. In that pod only they have to prepare the dosa. It means the containers, right? The pods are running inside a node. Let's say only node 1 is assigned. Scheduler has assigned for both the dosa. He has assigned only node 1. He has assigned two pods, P1 and P2. Okay, inside pod containers are running. So that is taken care by the worker, that is the chef, right? So this is basically the standard process. Okay, now the pods are running, it means the containers are running, it means the food is being prepared. When the pod is running, inside the pod container is running, it means the food is being prepared, the dosa is being prepared, right? There is somebody called as control manager. You see here, there is somebody called as control manager. What is his job? His job is to make sure that this process is running. The preparation of dosa is going on properly. That is his job. His job is to just check that whether the order which is given by the customer is being taken care properly or not. That is the job of the controller manager. So his job is to manage whether the dosas which I have told, whether the pods, whether inside the pod I am having container, whether they are working fine or not. That is taken care by the controller manager. Okay, so what are the things it does? What is the job of controller manager? Controller manager is the important person. Let's say when chef 1 was preparing dosa 1 and it got burnt, okay, then the controller manager's job is to tell the chef, no, this dosa is not right, customer will scold us, you prepare another dosa. That is the job of the controller manager. So he will make sure that the proper dosa is being made. That's what, if some failure is there, some burnt is there, right, half cooked, everything, he will be monitoring it. That is the job of this controller manager. Okay, so whether they are properly prepared or not, right? So this is the general process. I think you understood now what in etcd we are storing the orders. API server is the one who is receiving the request. Scheduler is the one who is deciding where the request has to go, who has to solve it, and controller manager's job is to make sure that the task which was given is properly executed by pods or not. That is the job of the controller manager, right? Cloud controller manager is nothing but receiving the request through API and giving it to the server. Sometimes the request might come through a cloud API or basic system API. So we have a cloud front-end manager which will receive the request and give it to the API server, right? So when we are talking about scaling here, so I think you got little idea about what is happening inside the restaurant and how it is matching with this manager, worker and the control plane, master and the workers. Okay, so scaling is achieved here. Let's say suddenly 10 people or the same customer orders, no, dosas are very good, you prepare 10 dosa for me. So I have to scale. I have to scale means I have to call the other chefs who are simply sitting idle. I have to increase the chefs, C4, C5, C6, right? So I have to increase the chef. So that also taken care by the manager, right? So these are few different what we say, no, the simple example or the working of the Kubernetes. Okay, if I summarize that, right, there is a customer, he gives a request, and where does the request go? Request goes to API server, and that request is stored in persistent store, etcd. From here comes the scheduler into picture. What is the job of scheduler? To assign nodes for the pods. Then he assigns worker nodes, he decides the worker nodes, he decides the chef. From there what happens? These worker nodes use the assigned pods to them, and inside pods they will do the service. Service means preparing the task, and from here their output goes to the customer again. So inside the pod the dosa is being prepared and it is being serviced to the customer, right? So this is the working of this Kubernetes. Okay, so we have API server, we have etcd, scheduler, controller manager, pods, and then we have kubelet and kubeproxy. Kubelet is one component for taking care of the health of the pod, and kubeproxy is responsible for communication between the pods, right? So we will understand more about this in technical terms. Now let's try to understand the components, right? So if you see, there are two different components inside the Kubernetes architecture. One is the control plane, the other is the node plane. This is the node region where we have lot of nodes, and this is the control plane, right? So Kubernetes cluster consists of a control plane and one or more worker nodes. So let's understand about the control plane components, right? So we have API server. Okay, the core component of server that exposes the Kubernetes HTTP API. So from the API server is the one through which we receive the requests, right? That exposes the Kubernetes HTTP API. Then there is something called as etcd. It's a database for Kubernetes, right? Consistent and highly available key value store for all API server data. Whatever requests are coming to this API server, those requests are being recorded and stored as key value inside this etcd, right? And then we have the third component, scheduler. What is the job of scheduler? Looks for pods not yet bound to any node. Some free pods it will look for and assign each pod to a suitable node. So pods we have to create and assign them. So it will look for some free pods which are not assigned to any node. So the scheduler's job is to assign the pods to the nodes. Node is nothing but a virtual machine or a physical machine. Inside each node I will have multiple pods. Inside each pod I will have multiple containers, right? So scheduler's job is to assign the nodes, the pods to the nodes. Next, controller manager. What is job of controller manager? runs controllers to implement Kubernetes API behavior. Whatever request came to us, the API request, whether it is properly being managed, whether it is properly being served or not, that will be taken care by the controller manager. So, controller manager's job is to take care of that request, whatever request has come from the outside customer, whether it is being satisfied properly, whether it is being answered properly or not. That will be taken care by the controller manager, right. And then we have cloud controller, if the underlying there is a cloud provider, so to coordinate with that cloud provider, we have a cloud controller manager. This is an optional one, but if you are using cloud for your deployment or running of your application, then we need to use this cloud controller manager. So, integration with the cloud providers, because your application, your containers, everything is in the cloud. Maybe your virtual machines or your nodes are running inside the cloud. In such case, we need to use this cloud controller manager. So, these are the components here, right. So, we are talking about cloud controller manager, API server, etcd, scheduler and controller. So, all this is control plane. These are the control plane components, right. So, next, then we have node components. Okay, then we have something node components. So, what is this node components? So, the other side of that, here we see the different nodes, right. Here what are the different components available inside a Kubernetes architecture. So, what are then the node components? Run on every node, maintaining running pods and providing the Kubernetes runtime environment. So, they are the virtual machines of the physical machines. So, we have something called as kubelet, ensures that pods are running including their containers, because we are telling inside each pod there are multiple containers. This is pod 1, then I have pod 2, C3, C7, sorry, this should be C8, let us say, and C2. There is another pod which will be running only container C4, right. So, whether the pods are working fine or not is taken care by the kubelet. And then we have kubeproxy, maintains network rules on nodes to implement services. So, how the communication between the pods should happen, that is taken care by the kubeproxy. And also we write some network rules with kind of firewall, all that you can set it here. What kind of request can come to your pod, which request can talk between these two pods, what kind of communication can happen, all that is done inside the kubeproxy, right. And the final one is the container runtime, because this containers has to run, no, inside the pod the container has to run. We know, we have seen how in using Docker desktop how we can start and stop the containers, right. So, software responsible for running containers, container runtime is required for running the containers. So, when I am having pods here, inside pods when I am having containers, whatever environment or the runtime is required for running these containers is supported by the container runtime, right. So, container runtime takes care of the working of the containers, right. So, this is the master worker architecture, okay, master worker architecture of Kubernetes, right. So, if you see, API server is the one which receives the request, this is for integrating the cloud services. Cloud controller is responsible for monitoring whether the API request which has come is it working properly or not. Then we have etcd, where we store the request which has come to API server in form of key value. Then we have kubelet, who is responsible for the health of the pods along with the containers, and we have kubeproxy for managing the communication between the pods, and there is a scheduler whose job is to assign pods to the nodes. There are some virtual machines or there are some physical machines which we call them as node. So, I have to assign some pods inside the nodes, right, and then this is the node and this is the control plane. So, these are the different components, as well as this is the master workers architecture of Kubernetes. So, this forms the fundamental thing. This is all in the back end. What you see in the front end is different of Kubernetes. right? All this part comes in the back end of Kubernetes. But once you see the front end of the Kubernetes, the tool, if you see, you will only see that you will be frequently hearing the word node, you will be talking about pods, right? This and all these things exist in the back end. But for you, you will see the node, you will see the pod, inside pod you will see the containers, they are working fine or not, right? Internal functioning is explained through this architecture. Okay, so this is about the master worker architecture of Kubernetes.